Hi everybody. Today we are going to show you demo of L2 Gateway solution with Kilo code base. So here is the topology diagram of the demo as we can see in the screen. So we have a Neutron server. We have a network node on which the L2 Gateway agent is running. We have the compute node on which we have the tenant VM with the IP 41.41.41.4, and we have the HP 5930 top of rack switch gate as the gateway, as the hardware L2 gateway, which is connected to the HP 5900 switch via 40 gig connector. And this interface of the 5930 top of rack switch is named as bridge aggregation 2, and it participates in the VLAN ID 1801. And the bare metal server with IP 41.41.41.100 is connected to the HP 5900 switch. So as we can see, the network node, the VTAP IP is 100.80.0.60, and the compute node VTAP IP is 100.80.0.61, and the VTAP IP of the 5930 L2 gateway is 100.80.10.102. So with all these nodes, network node, compute node, and the 5930 gateway, they are having this IPs as both management and the data path IPs. So with this in mind, let's go to the real demo of the use case. So let me show you first the OSDB dump of the 5930 gateway. So we can see that the OSDB tables are almost empty, but we have in the physical switch, we have the physical switch table that has the information about the physical switch, that is cell 08593002 IRF is the switch name, with the VTAP IP of 100.80.10.102 as we saw in the diagram. And in the physical port we have the interface of bridge aggregation 2. So now let us go to the agent, L2 gateway agent running on the network node. We have to, in the ini file, we have to configure the IP address of the L2 gateway, that is 180.10.102, and 6632 is the TCP port on which the OSDB server is configured. Now let's go to the Neutron server, and we can show you how L2 gateway service plugin is configured in the neutron.conf file. So you can see that in the service plugin we have configured the L2 gateway service plugin. So once these configurations are done, and when the Neutron server and the L2 gateway agent are restarted, we can see the L2 gateway agent in the Neutron agent list command output. You can see here, the L2 gateway agent is listed. So now let's go to the MySQL tables of Neutron. There is a table called physical switch. So in this the physical switch is listed, and there is a physical ports table in which the physical port is also listed with the bridge aggregation 2. Now let us let's see which networks we have already. So we already have one network created to save time, that is N1, and we have already one VM created on this network with the IP 41.41.41.4. So let us create the gateway now. So in the gateway create command, we need to specify the switch name, that is cell 08593002 IRF, and the physical port name, that is bridge aggregation 2. 1801 is the VLAN ID as we saw in the diagram. This 1801 VLAN ID is the VLAN ID where the physical port is connected to. So we can see on the compute node the tunnels. So we can see that there is only one tunnel that is to the network node, see that there is a tunnel to the compute node, but there is no tunnel to the switch yet. Now let us go and create the gateway connection. So in the network gateway creation, okay. So first let us try to ping the bare metal server from the virtual machine. You can see that the ping fails, and from the bare metal server let us ping the virtual machine. As we can see from here also, we are not able to ping the virtual machine successfully. Now let us create the connection with the gateway 1 and network N1. Okay, so the connection is successful. Let us see the OSDB dump on the switch. We can see that there is a there is a binding that is created on the physical port, that is 1801 is the VLAN ID, and the other one is the network information, that is VNI. And also we can see that the ucast MAC remote table has now the max of the VM and the DCP port of that network. With this configuration, we'll be able to ping the bare metal server from the virtual machine, as we can see. And from the bare metal server, we can see that it is able to reach virtual machine. So let us keep this ping operation. Let it go on, and let's see what happens if we. And we can also now let's see the tunnels from the compute node. See, now we can see that the tunnel is been created from the compute node to the physical switch. So you can see the remote IP is 180.102, and now let us go to network node and see the tunnels on the network node. You can see that from the network node also there is a tunnel created to the gateway 180.10.102. So let the ping operation continue, and what we'll do, we'll try to delete the connection. Let's see what happens to the ping. So once the connection is deleted, we can see now here that the virtual machine is not able to reach the bare metal server, and also the bare metal server is not able to reach the virtual machine. Now let us go to the OSDB client dump. We can see that the VNI to VLAN binding has been removed. The MACs are also removed from the ucast MAC remote table. The table is empty, and we can now see we can go to compute node and see the tunnels in the OSVSCTL command. We can see that the tunnel has been destroyed to the switch, and also from network node. Let us dump the tunnels. So we can see that the tunnel to the physical switch also has been removed from that network node. So this completes our demo. Thank you.